So here let us do a simple problem Laplace transform so that I can show you how to draw the region of convergence. So here the question is, find the Laplace transform and the ROC of the signal x of t is equal to e raised to minus at u of t. Okay, so here first, for any of these kinds of problems, we always start the problem by writing the Laplace transform equation. So we know that the Laplace transform of x of t is equal to integral minus infinity to plus infinity x of t into e raised to minus st dt. Okay, now here I substitute the value of xt in the given equation. I get integral minus infinity to plus infinity e raised to minus at u of t into e raised to minus st dt. Okay, so we know what is u of t. U of t is a unit step signal because u of t is equal to 1 when t is equal to 0 to infinity. Otherwise u of t is equal to 0. Right? This is how we define the unit step signal. So I'm going to apply this equation over here. I get the Laplace transform of x of t is equal to integral 0 to infinity e raised to minus at into u of t becomes 1 into e raised to minus st dt. Yes, this is how we define the equation. Okay, now I am going to combine these two exponential function. I get integral 0 to infinity e raised to minus s plus a t dt. Okay, so now I'm going to stop my problem right over here because from here we can easily find my ROC. Okay, so we know that the condition, the Dirichlet's condition states that integral minus infinity to plus infinity the magnitude of x of t into e raised to minus sigma t dt must be less than infinity. This is my Dirichlet's condition, right? So this is my condition to be satisfied. That means I need to find the value of sigma, the range of sigma. This range of sigma is what we call as ROC. Alright. So once if you look over here very carefully, you can see that the exponential function, the power of the exponential function is negative, e raised to minus sigma t. That's because if we multiply a signal with its decay exponential function, that signal reduces to 0 at infinity. Thereby we are forcing the signal to converge. You see, we are forcing the signal to a converging value by multiplying e raised to minus sigma. This is called as the decay exponential function. So which means that we can define the ROC only if the power of the exponential function is negative. So here, as you can see, the power of the exponential function must be negative, right? Here it is s. Inside this s there is sigma plus jo, right? So if I substitute here s as sigma plus j ohm, I will get minus of sigma plus j ohm plus a into t, right? So my ROC is defined when s plus a must be greater than 0 because the power of the exponential function must be negative. So since there is already a minus sign over here, that means s plus a must be a positive value, right? Because if this is also negative, then negative plus negative becomes positive. That's not what we want. What we want is that the power of the exponential must be negative. So since there is already a minus sign over here, that means s plus a must be a positive value. Or in other words, the real part of s. The ROC function is defined as my sigma, or the real part of s must be greater, plus a must be greater than 0. Or in other words, it's also, you can also write sigma over here. Both are correct. Okay. Or in other words, the ROC is defined as the real part of s must be greater than minus a. This is my region of convergence. Okay, or you can also write like this: sigma must be greater than minus a. Okay, So this is what we call as the region of convergence. So here in this problem, the region of convergence is that the value of sigma is from minus a to plus positive, greater than minus a. So minus a to plus positive, any value from minus a to plus positive is the region of convergence. This is what we define as the region of convergence, that is the range of sigma or the values of sigma when the Laplace transform exists or when the Laplace transform converges to a simple value. Okay, so now I am going to continue my problem as usual. So I can now write my Laplace transform of x of t is equal to integral 0 to infinity e raised to minus s plus a into t dt. This is also equal to, I can write it as minus 1 by s plus a into e raised to minus s plus a into t from 0 to infinity. I can take this factor common. This will becomes minus 1 by s plus a into e raised to minus s plus a into t from 0 to infinity. Okay, this in turn becomes minus 1 by s plus a into e raised to minus infinity minus e raised to 0. E raised to minus infinity is 0 and e raised to 0 is 1. Therefore, the answer is minus 1 into minus 1 becomes plus 1. So, the answer is 1 by s plus a. Yes? Or in other words, the Laplace transform of e raised to minus at into u of t. Just imagine this is also called as a causal signal, right? E raised to minus at u of t is also a causal signal. This is equal to 1 by s plus a. Okay, and the ROC of this function is defined as sigma must be greater than minus a. This is how we define the ROC. Now I want to draw my region of convergence. Okay, I want to visually see my region of convergence. Okay, that also you should draw. When they ask ROC, you should also draw and show the ROC. Okay, so how to draw the ROC is first we draw the S-plane. The S-plane. So what is an S-plane? S-plane is a plane that shows the values of sigma and JO. Okay, that is, it is a two-dimensional graph. It is a two-dimensional graph in which the x-axis represents the real part of S and the y-axis represents the imaginary part of S. This graph is called as the S-plane. This graph is what we call as the S-plane. Okay, this is also called as, you have heard of this. This is also called as the pole zero plot. Right? This is also called as the pole zero plot because in some problems we can also mark the poles and zeros in this graph. Right? If you remember that is, if we just equate the numerator function to 0 and find the value of s, that is called as poles, and if we equate the denominator function to 0 and find the value of s, that is called as poles. That is called as poles, and if we equate the numerator function to s, then that value of s is called as zeros. So this is also called as a pole zero plot. Okay. So here I want to mark my ROC. So what is ROC is, the answer I got was sigma must be greater than minus a. This is the answer I got. Sigma must be greater than minus a. So to do that, first I mark my value of minus a over here. It can be anywhere on the negative axis, negative x-axis. Okay. So my ROC can be shaded like this. Sigma must be greater than minus a. The value of j ohm can be anything. That's what it means. The value of j ohm can be anything, but the value of sigma must be greater than minus a. So any value from minus a to infinity will be enough to define the Laplace transform of the given question. That is the meaning of this. Graph. Okay, this is how we represent the region of convergence. Okay.